Now look at this.
What's up, about penguins? Today we do topic 7.8 on continuing evolution. Real quick, gotta remind you, it's populations that change. So when we talk about evolution, we're talking about that a population of bacteria, a population of horses, a population of something has changed due to the environmental change. So as something changes, a certain trait is more or less favorable, and because of that trait being favorable, it's being selected for. So we're seeing an increase of that trait in the population, or it's selected against, so we see a decrease of that trait in the population. So based on that, we know populations are never perfect, okay? Evolution is a constant, ever-changing event because the environment is always changing. So here you can see the evolution of the forefoot of a horse. And so you can see over time that from 55 million years ago, there was 5 little components. And now we have these 3 components that look to be kind of fused into one. So shout out to Mr. Todd Ryan. As we were talking about it after dinner one at the AP reading, he mentioned how the vegetation of Earth has changed over time. So back in the day, horses were a lot smaller. Okay, you can kind of see from the picture that they were very, very small. And the way that the forefoot was designed was so that it could work through all of that vegetation, that deep vegetation. And over time, the forest kind of became more of a grassland. And as that vegetation changed, the horse had to get longer legs, longer necks, in order to survive in that environment. And so you can kind of see over time how that forefoot has changed. So why do you need to get a flu shot every single year? Well, influenza is an RNA virus. And so it's going to go through constant mutations every time it replicates. And these mutations can accumulate. So your flu vaccine from last year has certain mutations in it that your body was used to fighting against. And so this year's vaccine is going to have different mutations to allow for you to have a different strain to be protected against. And I've already run over on time, so I'm just going to keep on going. So another example of continuing evolution has to do with antibiotic resistance. And so I found a video from Harvard Medical School that's even better than anything that I can explain. So let's take a look at that video real fast. It's on Science News.
So what we ended up building was basically a petri dish, except that it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic. On the outside, there's no antibiotic. Just in from that, there's barely more than the E. coli can survive. Inside of that, there's 10 times as much, 100 times, and then finally the middle band has 1,000 times as much antibiotic. And then across the top of it, pour some thin agar that bacteria can move around in. The background is black because there's ink in it, and the bacteria appear as white. First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right. It's resistant to the antibiotic, it spreads, until it starts to compete with other mutants around it. When these mutants hit the next boundary, they too have to pause and develop new mutations to make it into 10 times as much antibiotic. And then you see the different mutants repeat this at 100. And after about 11 days, they finally make it into 1,000 times as much antibiotic as the wild type can survive. And so we can see by this process of accumulating successive mutations that bacteria, which are normally sensitive to an antibiotic, can evolve resistance to extremely high concentrations in a short period of time.
So I think it's important to note that the bacteria had a mutation. That mutation allowed for it to survive in that higher concentration of the antibiotic. It's not that the antibiotic made the bacteria resistant. It's that it allowed for that resistant bacteria to be selected for, and then that's became the whole population. AP Bio Penguins are just success. Bye, y'all.